Okay, ladies and gentlemen, today we're going to learn about a hyperbola. Okay, so the definition of a hyperbola is a set of points in a plane that the difference of whose distances from two fixed points is called the foci is constant. So basically, if you look at this drawn on the right, you've got a point on the hyperbola. That distance, D1 and D2, the difference in that is constant. If you remember from ellipses, it was the sum of them, right? It was constant. On the hyperbola, it is the difference of them. Parabola would mean that the distances were the same, right? And then ellipses, well, we did ellipses, right? Circles would be a constant distance, right? All the way around from the center. So that's how these things are formed. We've got different parts on this. So you just got to make sure you understand what the parts are. But by now you ought to know some things like the focus, right? The vertexes, correct? Transverse axis, and then the center. Okie dokie. Any questions on that? Y'all good? All right. The standard form of equation is exactly there. X squared over a squared minus y squared over b squared, or y squared over a squared minus x squared over b squared. Note that the y squared and the x squared swapped places. The numerator swapped this time. Excuse you. All right. As opposed to the denominators. So make that a note. This is if it's at the origin, right? Which is probably the easier of them. And that should be really your formula sheet that I gave you. If you just drop the h's, you've got this equation, right? Because I gave it to you if it was moving. C squared equals a squared plus b squared, right? So those are just some things that you need to be aware of. Here they are graphed. You can kind of look at them, the different forms. Your A and your B's. Your A's are going to be where your vertexes are. Okay. Your B's are going to help you to get basically the box to help you draw the asymptotes here. Y equals b over ax, and then you have y equals negative b over ax, right? So that'll help you to determine how much it goes out, right? Asymptotes, if you don't remember, is a line that the function approaches but never touches. Okay, it'll get closer, closer, closer. It's like taking half of a number and continue taking a half, right? Can you ever get to where you can never take a half of a number? Nah, it may be all the way a lot of zeros, right? But you still have to take half of it. So the asymptote just gives a clear path of how the hyperbola is going to go out. So if you note that this is a box, see this box right here? We're going to draw that box. That box is going to help you when it comes to graphing to be able to know how to do those asymptotes. But it's nothing more than b over a, the slope, right? So just remember when we get to that, it's going to be something as simple as that. Here they're calling out the asymptotes, y equals b over a and y equals negative b over a. If it's vertical, then it'll be a over b. So just note that that's, and you've got them right here. You've got how they're going to change, right? So I'd make sure I made that little note on my formula sheet. If it's vertical, it'll be y equals a over b. If it's horizontal, it'll be plus minus b over a. this right here. This is horizontal. The first picture is horizontal, right? The asymptote equations, y equals, put plus and minus because you're going to do both ways, right? B over AX. And then if it opens up and down, if it's orientated vertically, then it'll be y equals negative A over plus minus A over B, right? That's going to change depending upon how it's orientated. So you need to make sure you know that. Any questions on that? Anybody? Still copying? Need some copying? Still copying? Okay. All right, so here's the first thing we're going to look at. Today's lesson is going to be converting between different forms. General conic to standard, and then what? Standard to general conic, right? All right, so what do you think our first thing is to do here? We need to group variables, right? So let's see how well you can take this, because we've done this on ellipses, right? So let's see if you can group them and everything. Now, I will tell you this. Listen to me. How do you know how to write the equation if it's vertical or horizontal? Look at your squared term. Look at your squared term. If it's a y squared, then it's going to be horizontal. If the y squared is negative, right? If the x squared is negative, guess what? It'll be vertically, right? The coefficient for the y squared term here is negative 4. That means that this hyperbola is going to be left or right, which means your x is going to be positive, right? Your coefficient for your squared term is positive, right? If that was to swap, if your squared term had a negative coefficient and your y squared term had a positive, then it would open up and down. Okay, so just kind of be aware of that, because where you put those in the sequence matters. Okay, folks, I'm going to give you a good minute and a half. Okay, ladies and gentlemen, the first thing we got to do is we need to determine whether our x squared has a positive or negative, or a y squared has positive or negative. That determines how the orientation is, right? So our x squared term is positive, so it's going to be left to right. So we're going to put the x's first. So 9, better if I grabbed a pen. 9x squared plus 144x minus 4y squared plus 48y equals negative 288. Any questions about that? Anybody? We just grouped them. The next thing that we have to do has to deal with factoring, because we cannot complete the square until we have a positive 1 on the coefficient of the square term. So in this one, I need to pull out a 9. So that's x squared plus, how many times will 9 go into 144? 16. All right, so that's plus 16x. Then we have something that's going to complete our perfect square trinomial, right? And then we're going to have minus 4. Then we're going to have y squared minus 12y plus something, right, equals negative 288. Now, I'm going to put plus 9 times something plus negative 4 times something, right? Okay. What is half of 16? So I'm going to put a positive 8 squared. That's 64. There you go. So I'm going to put you 64 over here. Negative 12, half of it is negative 6. Square it, and you get 36. I'll put 36 over here. We should, at this time, be able to write our perfect square trinomials in factored form, right? So 9 times x plus 8 squared minus 4 times y minus 6 squared equals, well, what's 9 times 64? 576, so that equals 576. What's negative 4 times 36? 144? Negative 144, right? All right, so we got negative 288 plus 576 and a positive plus negative 144, right? So what does that give me? How much? Positive 144? Ladies and gentlemen, we got one thing left. What do you think it is? Yeah. Why? Why do we have to divide it by 144? Your right side of your equation has to equal 1, right? Just like the ellipses, correct? Okay, so we'll divide both sides by 144. It should be something that 144 go into, right? So that would be x plus 8 squared over 16 minus y minus 6 squared over who? Negative what? Negative 36? Yeah? Then equal what? 1. That it? Uh-oh. I can't say negative 36 down here, can I? I've already got the negative up top, right? No. You'll be plus the A and minus the A from the center to get the vertex, and then you'll have the foci, which will also be plus and minus from there. So it's kind of like on the ellipses where we had the vertices, right, from the center, 2 directions. Same thing here. All right, we're good? Any questions on this? Anyone? Everybody seeing things that we've done before? Are you starting to see patterns? Okay. Listen, it's the same process. Only thing changes is the numbers, right? Excuse me. All right. Let's look at the next one. Next one I want you to do is this one. So I'm going to give you about 2 minutes to work it. Let's see what you can do. Okay, let's look at this one. My x squared term has a positive coefficient. My y squared term has a negative. So that negative coefficient is going to go second, my grouping, right? I'll do my x's, then my y's. If it was flipped, then I'd have to flip my grouping, right? So I've got x squared plus 14x minus 25y squared plus 50y equals 76. Anybody know what I can do right here right off the bat? I can complete square right off the bat on this one, right? I don't have to worry about factoring anything out because this is a positive 1. But just for general purposes and to keep everything straight, I'm going to break it down and do this, right? I'm going to factor out negative 25 here. Oh, it's 14. Thank you. I'm going to factor out negative 25, so there. So what is that? Negative 2y, right? Equals 76 plus something, right? And then plus negative 25 times something. So that would be plus 7 squared, which is 49. So there's my 49 over here. Now looking at this, it'd be negative 1 squared, so it'd be positive 1. Right? Okay, now I'm ready to write my perfect square trinomials in factored form. Anybody got any questions up to there? Anybody? Okay, let's proceed. So I've got x plus 7 squared, right? Squared minus 25 times y minus 1 squared equals, what does this over here give me? 100 period? 100 period. 100. Okay, 76 plus 49 gives me probably what? 125 minus 25 gives you 100. Okay, ladies and gentlemen, here we go. Last step. Divide everything by what? 100. What's that? 4 equals what? All right. How's this orientated? Horizontally. Who came first? The x squared, right? Yeah, if the y squared come first, then it would be, right, vertical. Okay. Who does the 100 represent? A squared. Who does the 4 represent? The b squared. Okay. And we need A and B off of them, right? Okay. Any questions? Yes, ma'am. I'm not going to do number 4, but I'll do number 5. Number 4 is not that hard. You don't have a linear term on something. No, it'll be okay. I promise you. All right, number 5. And then this is the last one on this one. Here's your hint. Look at your squared terms. The one that's negative needs to go second, right? The one that's positive needs to be in your first grouping. What now? No, ma'am. One be positive, one be negative. Okay, ladies and gentlemen, you know that your coefficient, your square term for x is negative, so it will be in the second grouping, and this is what I mean by the second grouping. The y's will come first, since it has a positive coefficient, and then the x's. So we'll pull out a 16 here. That's y squared. That's 16, 256 is what, 16? Yeah? Okay. Minus 25. Okay, good. X squared minus what? Huh? Yes, plus, you're right. Plus what, babe? 10. Yes. X. Boom. Okay, so we've got plus 16 times something, and then plus negative 25 times something. Any questions up to the green? Anybody? Everybody is able to do that and understands why you have to do that. Because we can't complete the square on something until we have a positive 1 in the coefficient, right? Okay, here we go. Plus 8 squared, because it's a linear term, halved and squared, so that's 64. So I'll put my 64 over here. Positive 10, it'd be plus 5 squared, so that's 25. So I got 25 over here. Now I can write it. Minus 25, x plus 5. Sorry. X plus 5 squared equals what, folks? How much? 400? Y'all concur? Okay, so that equals 400. Ladies and gentlemen, what we're going to do? Divide it and we're done. Exactly correct. How many times was 16 going to 400, folks? 25 times? How about 25 into 400? 16. Do y'all see something there? Y'all see a pattern there? Huh? Is it? Does it work like that? I don't know. We have to go back and look at number 1, number 2. See if that's true. Yes, ma'am. At the top. It has to go on the top, not in the denominator. Okay? All right, so 16 became the denominator here. 25 become the denominator there. Let's see if that's a pattern. No. Not on that one, is it? On this one? No. So what do we call this little phenomenon right here? What do we call that? What 16 became down here and 25 became? We call it a quinky dink. Right? All right. I want to look at one other thing before we go. And this is for y'all to, wait, got to go to 9. There. Can you expand that? Can you expand it? Huh? That's the second part of this, okay? So you expand the top and then multiply everything. Well, multiply everything by 36 times what? 9. That would clear your fractions, right? 36 times 9. You ain't got to find the LCM, right? I will show you the answer to this one. That's what I get, but it's probably because they're doing the LCM, and we're probably not, okay? So finish that for homework. Yes, front and back. Got to be able to do the back. It looks very familiar to what we've done before. It just has a negative in it as opposed to a positive.